presentation to you this morning will be on the new provisions in TGD F 2019, and there is a particular focus on the validation of ventilation systems for all NZEB dwellings. So I will lay out first the context in terms of the EPBD and the transposition in Ireland, and the importance not only of energy efficiency in dwellings, but also in their air quality. Okay, and we also laid in the context of NZEB in Ireland in 2022. Where are we with NZEB dwellings in Ireland in 2022? And a third layer of the context, what happens when member states start measuring actual airflow in NZEB dwellings across Europe and in major innovations. So what is a ventilation compliance rate when we start measuring? Then once I have presented those different contexts, we'll move to the new provisions in TGD F, and we'll focus on the validation of ventilation systems for NZEB dwellings and major innovations. So the EPBD started back in 2002, and in 2019 we transposed Article 7 and Article 9, namely that member states are to ensure that all new buildings are nearly zero energy buildings NZEB by 31st of December 2020. So that was for dwellings. Building other than dwellings was introduced previously 2 years before. And Article 7, that major innovations are to be at cost optimal level in building codes. Other articles are being introduced through our climate action plan also. One important amendment that was introduced in the EPBD, so the Energy Performance of Building Directive from Brussels in 2018, was to highlight the importance of indoor air quality as much as energy efficiency. Particular Article 7 states member states shall encourage in relation to buildings undergoing major innovation, high efficiency alternative systems, insofar as this is technically, functionally, and economically feasible, and shall address issues of healthy indoor climate conditions, fire safety, and risks related to intense seismic activity. In Annex 1, the energy needs for space heating, space cooling, domestic hot water, ventilation, lighting, the regulatory load, and other technical building systems shall be calculated in order to optimize health, indoor air quality, and comfort levels. Okay, so the EPBD is as much about energy efficiency as indoor air quality. It's not only about energy efficiency. Okay, there's more than just Part F. Part F is very much on a similar par from an EPBD level. So we've introduced it in various steps since 2002. In 2007, we introduced new provisions for renewables. There were absolute provisions, and with regards to air tightness, we started the provision to measure the air tightness for a certain number of dwellings. In 2011, we improved the provisions for the fabric performance. For example, we reduced the U values of the walls from 1.27 down to 0.21 watt per square meter Kelvin for the walls, windows from 2.0 down to 1.6. And in 2019, the latest improvement in terms of fabrics and air tightness led to NZEB, and NZEB dwellings in 2019 are 70% more energy efficient than in 2005. Okay. From a compliance point of view, an NZEB dwelling needs to have a maximum permitted energy performance coefficient of 0.30 and a maximum permitted carbon performance coefficient of 0.35 calculated with DEEP, and a minimum ratio of renewable energy of 20%. Air tightness in 2019, from 2019, all dwellings should be air tightness tested. Not 1 in 4, not 1 in 10, all new dwellings should be air tightness tested. Okay, that includes all apartments in an apartment block should be air tightness tested. And we have reduced the backstop value of the air permeability to achieve from 7 down to 5 cubic meters per hour per square meter. Okay. The test should be carried out by a person certified by an independent third party to carry out this work, NZEB or National Standard Authority of Ireland, the NZEB, certified by equivalent. The procedure for testing is specified in ISCN 9972, and it must include 2 sets of measurements for pressurization and depressurization. So an assigned certifier should provide an air tightness, a valid air tightness report with an air permeability not greater than 5 cubic meter per hour per square meter for all new NZEB dwellings. Building control officer should check for a valid air tightness test report with an air permeability not greater than 5 cubic meter per hour per square meter for all new NZEB dwellings. Okay. For this, the NZEB has created and managed a scheme, which is managed by Gary O'Sullivan, who is with us here today. They currently have 74 registered air tightness testers, okay, covering all the 4 provinces of the country. Okay, so there is no issue of supply to the market. And most of those guys will be also BR assessors, for example, or but ventilation validators as well, so that they can provide a very holistic approach to the building and certification to the building. In terms of indoor air quality and energy efficiency, in Part L 2019, so in TGD F 2019, we reduced the minimum provisions for specific fan power and heat recovery efficiency. So we moved from mechanical extract ventilation system, so we reduce the specific fan power of MEV from 0.8 watt per liter per second down to 0.6, and for a balance system from 1.5 watt per liter per second down to 1.2 watt per liter per second, and we improved the minimum heat recovery efficiency from 66 to 70%. When you look at the current market and you look at the average value from the SEI BER database, you can see that we had 0.28 for the SFP for MEVs and 0.76 for balance systems and VHR. And the minimum heat recovery efficiency is at 80%. So next year we'll be reviewing the cost optimal level, okay? And we'll be working with a top 25% specification from the SEI BER database. And you can see that the SFP for balance systems is at 0.50, and the heat recovery efficiency lies at 92%. So the industry, the ventilation industry, is way above or beyond the minimum provisions in TGDL. So you can expect this to change in the next version after we've done the cost optimal review in 2023. Okay. When we look also at indoor air quality and energy efficiency working hand in hand, I took here 3 examples from TGDL 2019. It's the same semi-detached house with 126 square meters floor area. Gas boiler and PV as a main space heating system, but 3 different ventilation strategies, okay? Continuous mechanical extract ventilation, example A, natural ventilation, example B, and mechanical ventilation with heat recovery in example C. And you can see that from an energy efficiency and from a heat loss point of view, there is very little difference between natural ventilation and continuous mechanical extract ventilation. From an energy efficiency point of view, the MVHR alternative is the one offering the least heat losses, okay, of the dwellings. But the 3 examples are NZEB compliant examples. So, continuing on the compliance examples, we had 1 compliance example in TGDL 2011. We moved to 6 in 2019 to reflect the market. So we reduced the primary energy use by 20% from 2011, from 56 to 42, and same reduction for the CO2 emission from 10 to 8 kilograms per square meter per annum. We introduced 6 examples for semi-detached house, but also apartments. Okay, currently in Dublin, with 70% of the new dwellings are apartments. So we need to reflect the market. And you can see that you can achieve NZEB compliance with different space heating strategies and ventilation strategies. So gas boiler and PV or heat pump and natural ventilation, mechanical extract ventilation or mechanical ventilation with heat recovery, achieving the same primary energy use of around 40 kilowatts per square meter per annum and the same CO2 emission around 8 kilograms per square meter per annum. So that they were in 2019. So in 2022, what does the market tell us, and what do NZEB new dwellings look like in Ireland in 2022? That is once again based on the analysis of the ACER-BR database from the end of the transitional period. First of all, the fabric is to passive level performance, okay, with triple glazed windows, okay. So that's in line with the U values we had put for the compliance examples. Wall at 0.13 watt per square meter Kelvin, roof at 0.11 watt per square meter Kelvin, and floor at 0.14 watt per square meter Kelvin. 75% of the new NZEB dwellings are using heat pumps for main space heating, okay? 15% are using gas boiler, 9% group heating, and 1% only oil heating, okay? And when you actually split the group heating, you will find out that heat pumps are used in 80% of the market, okay? And gas is at 19%. Okay. So heat pumps has taken over. When you look at the latest data from CSO, heat pumps has collapsed. They were at 47% of the market 5 years ago, and they're down to 19% now. Okay, 10 years ago, oil was at 30%, they're down to 1%. Okay, so fossil fuel is being phased out and is being banned without being banned in the regulations. Mechanical ventilation is a preferred ventilation strategy. In 2022, 28% of the NZEB dwellings are using still natural ventilation. 2/3 of the buildings are using mechanical ventilation, extract or with heat recovery. In 2018, so 4 years ago, it was 50-50. Natural ventilation was still at 50% of the market. Okay. In line with this, the average air permeability of a new NZEB dwelling is 2.8 cubic meter per hour per square meter, so it is less than 3. And that is in line with what we see 66% of the market is using mechanical ventilation. It also shows that the market has improved a lot with a lot more attention to details to achieve that air tightness level. So attention to taping and jointing, for example. Well, that's good. Just to remember, this is 2022, and the first time we introduced provision for air tightness measurements was in 2007. So we're looking at a 15 years improvement here. The average area is 34%. So your average NZEB dwelling in Ireland, 1/3 of the primary energy used in that dwelling comes from renewable sources on site or nearby. So ambient air for air to water heat pump or solar. And solar PV are used on 19% of the NZEB dwellings, which is in line with the 19% share of gas boiler. Okay. So that's what NZEB is. And to give you an idea of what's coming down the road, the new EPBD draft proposal that was issued by the DGNR in Brussels before Christmas is introducing a new standard by 2030 called ZEB, Zero Emission Buildings. And in the mind of Brussels, what we're looking at are dwellings with exactly the same fabric as NZEB. So they don't expect much changes on the fabric, with heat pumps, okay, and PV. So the change is it's not heat pump or PV, it's going to be heat pump and PV. Option A. Option B is going to be efficient district heating combined with PV. Okay, that's where we're going down the road from Brussels for ZEB. So we have well-insulated and airtight buildings. And here is a famous article published in 1992 in the past century, Build Tight and Ventilate Right, that was published by the BRA. When you have airtight building, and we have airtight building, 2.8 is the average value of air permeability, you need to ventilate properly. If that doesn't happen, you have a risk of having poor indoor air quality, high level of CO2, of humidity, mold growth, condensation, and a risk of overheating in the summer. But just to give a few examples. You will find many articles, okay, academic or in the specialized press, on the risk of having energy efficient buildings which are not properly ventilated. I've picked up one because it resonates in 2022 very much so. When you read it, it's quite chilling. This is a well-insulated, airtight house in Louvain in Belgium, okay? Brand new, I must say. Family of 5 moved in, 2 adults, 3 kids, okay? And from the first day, they developed symptoms of coughing, shortness of breath, headaches, pain in the limbs, nausea, diarrhea, and loss of taste. When you read this in 2022, you're thinking only one thing, you're thinking COVID. Those people lived in this house with COVID for 2 years, okay? So they complain, or obviously the contractor, something is not working here, this is not normal. When they had guests, the visiting guests were suffering from exactly the same symptoms. They checked the ventilation, and the ventilation rate, the actual measured ventilation rate, were at 30% of the minimum requirement in the regulations. And it was compounded by standing water in the ventilation ducting. Okay, so they could fix the ventilation rate, okay, that you can do, but they couldn't fix, and they tried on three occasions, the contractor tried on 3 occasions to fix it. And couldn't fix it because part of the ducting was going underneath the house and they couldn't reach it properly. So within 2 years, the local authorities were left with no other option but to condemn this brand new, well-insulated, airtight building and declare it unsafe for habitation. We don't want to see that kind of paper in Ireland declaring that a local authority somewhere in Ireland had to declare a brand new, well-insulated, airtight NZEB dwelling unsafe for habitation. Okay, so we need to have dwellings built tight and ventilated right. That's part L and part F working hand in hand. And in 2019, when we introduced them with exactly the same transitional arrangement, that they're working in parallel together. We have a maximum permeability set at 5 cubic meters per hour per square meter, and a continuous ventilation rate of around 0.5 air change per hour, and purge ventilation is around 4 air change per hour. We had a provision for an air tightness certificate to be done, but we had nothing for ventilation. So the question is, do we need to have ventilation validated by a third-party independent party? So you look then at Europe and member states, and you look at what happens when we start measuring actual flow rates in EPBD dwellings, new dwellings. So in Ireland, in Galway, Dr. Mary Coggins did some measurements with buildings built in 2007 and found that 4 in 5 dwellings did not meet the minimum requirement of 4.5 air change per hour. So that's a 20% compliance rate. In Scotland, 2015, 12 in 18 dwellings, the building rights in 2015 did not meet the minimum airflow rate requirement. And with regard to mechanical ventilation with heat recovery, more than half were imbalanced. That means that the supply airflow rate was greater than 15% above the extract airflow rate. And actually 1/3 were significantly out of balance, more than 30%. Okay, so that's here, compliance rates of 33%, 1 in 3. France, they looked at 2 studies, they looked at 1,287 new dwellings and found that 68% were not compliant. So that's a compliance rate of 32% when you start measuring airflow rate in France. Another study was they looked at 21 low energy houses, and not one of them, that 0% compliance rates, were failing to meet the minimum requirement. Okay, and the reason for that were, number 1, installation and design equally, but also at user level, maintenance and operation. In the UK, more recently, 2016, they looked at 33 new dwellings in 6 sites. Not a single one complied with building regs and ventilation. 0% compliance rate. And more recently in France, in 2018, they redid the same study that they did before. 70% of new dwellings ventilation system did not meet the minimum requirements. So nothing learned in the space of 5 years. And more recently, in the UK, AECOM carried a similar study for the Ministry of Housing, Communities and Local Government. and found that 16% of new dwellings with MVHR were installed incorrectly, 16% compliance rates, and for naturally ventilated homes, only 2 in 55 met the guidance in ADF, document F, and with regard to continuous mechanical extract, only 1 in 5 met the guidance published in the ADF. That's a 4% compliance rate. So when member states start measuring actual flow rates, the compliance rate is somewhere between 33% and 0%. So we do want ventilation systems to be validated by a third party. On the back of that, in the EPBD in 2018, the Commission undertook under Article 19A to carry out a feasibility study on the inspection of standalone ventilation systems. And for that, they contacted 250 stakeholders throughout the industry, throughout Europe. Okay. Question, your opinion about current overall performance of installed standalone ventilation systems? 15% only thought back in 2019 that they provided good in their air quality and energy efficiency, only 15%. 85% thought that there were failings on either IEQ or energy efficiency. What are the reasons for the poor performance? Well, the end user, they don't know, lack of awareness, maintenance, okay? And I give you some chilling example of maintenance of MVHR later on. Commissioning, installation and design, okay? What would be the impact of initial inspection if we were to make it mandatory? Better energy performance and better indoor air quality. Remember, the EPBD is about energy efficiency and indoor air quality since 2018. And that is the industry that is saying that. And who should do this inspection? 80% majority are calling for an independent inspector. Not the designer, not the installer, not the owner. An independent inspection. Do you believe a systematic inspection should be considered? 80% were in favor of a mandatory or voluntary system. And actually for new dwellings, most of them were asking, 60% were asking for a mandatory inspection. Okay. So that was Article 19A feasibility study. And I concluded with a look at member states at the end of 2021. What's happening? Well, a mandatory inspection or validation is required in 3 member states for residential buildings: Ireland since 2019, Belgium and Poland. It is mandatory for all new residential and non-residential buildings in Sweden and Finland, okay? And France introduced the RE 2020, and since the 1st of January of 2022, every new NZEB dwellings must be validated. From the 1st of July 2022, that's in 2 months' time, every new schools and offices. And from the 1st of January 2023, every new buildings. So what I'm trying to tell you is that this is not a fad. Okay, you can see other countries like Netherlands and Germany having voluntary schemes. This is happening, and this is not going to go away. Who is allowed to do the inspections? So in the countries where it is mandatory, it is an independent inspector, And in the countries which have gone for a non-mandatory, so voluntary scheme, it is the installer. So in Ireland, when the inspection is done by the installer, it is called self-certification. And we know from past experience that self-certification does not work. It led to the introduction of SI 9 of 2014, BICAR. So in Ireland, we're not going down the road of self-certification, we're going down the road of mandatory validation. When you look at the controls, what do they control? Mostly IEQ, whether it's voluntary or mandatory. They are always controlling IEQ. So IEQ is really the target of ventilation systems, indoor air quality, nothing else. And the periodicity of inspection or validation, whether it's mandatory or voluntary, it's once at the end, at the completion of the building, okay, before moving in. So that's the context at the end of 2021. And in that context, I'm going to go through the new provisions we introduced in TGD F 2019. So just to reflect the new backstop value for air permeability, which was 5 cubic meter per hour per square meter introduced in TGD F 2019. Natural ventilation with intermittent extract ventilation can only be used when the permeability lies between 3 and 5 cubic meter per hour per square meter. And mechanical ventilation, whether it's CMEV or mechanical ventilation with heat recovery, can be used regardless of the permeability range below 5. Okay. Clause 1.2.4.1 states where the intended design is greater than 3 cubic meter per hour per square meter, and the actual construction achieves a lower value, then appropriate additional measures should be implemented to ensure adequate ventilation. That means retrofitting a mechanical ventilation system. That's what this means. Not drilling holes in the fabric. Okay. That also means this for designers that if you are designing a dwelling where you want to use natural ventilation and you can achieve NZEB compliance with natural ventilation, you should be designing at 5. Not 3, okay? Not 3, because if you're lower than 3, there is no room for maneuver. If you are too high at 5, you can move down, okay, easily. So for designers, if you're designing at natural ventilation, you're going at 5 cubic meter per hour per square meter. If you need to go at 3, then forget it, go for mechanical ventilation. To reflect those are the lowest air permeability values, we've had to increase the equivalent area of background ventilators by 40%. So for habitable rooms, that is a ventilator with an equivalent area of 7,000 square millimeters. So that is a circular pipe with a 100 mil diameter. Okay. Clauses 1.2.2.1 and 1.2.3.1 states that the centralized continuous mechanical extract ventilation or MVHR system should be capable of 1, providing adequate general ventilation at all times. At all times. It's continuous. And of meeting requirements of extract ventilation that may need to be made from time to time. What does that mean? So clauses 1.2.2.2 and 1.2.3.2 gives you the calculated general ventilation rate that should be made at all times, okay, to demonstrate prima facie compliance. This ventilation rate is determined as a greater of 2 calculations. One is based on occupancy of the building, the other one is based on the floor area, okay? And one thing we introduced in 2019 is that we change the occupancy from 2 occupants in the main bedroom, 1 occupant in the other bedroom, to 2 occupants in the first and second bedrooms. This is to reflect, when you look at the data from CSO, the occupancy of dwellings has gone up, and we need to reflect that in the occupancy calculation. So we take a typical Irish semi-D house, 100 square meters floor area, 3 bedrooms. That means 2 persons in the first bedroom, 2 persons in the second bedroom, 1 in the third, 5 people. 5 people at 4 liters per second per person, that's 20, plus 5, that's 25 liters per second. That is the first calculation based on occupancy. And based on the floor area, 0.3 liters per second per square meter times 100 square meters, that gives you 30 liters per second. The greater of the both values is 30. The minimum general ventilation rate to be met is 30 liters per second at all times, continuously. So the extract rate that must be made from time to time are given in tables 1 and table 2, and they're in the wet rooms, okay? And the same for CMEV and MVHR. Control indicators. Control indicators should be in a visible location to the occupant, okay, and not in a remote location such as in the attic or above the ceiling. And the control indicators should indicate to the occupant 2 things: that the system is operating correctly, okay, and if a fault has occurred. It must indicate 2 functions. Information to the homeowner, okay. The owner of the building should be provided with sufficient information about the ventilation systems and their maintenance so that an effective and an efficient ventilation system can be operated and maintained. What does that mean? The way to comply is to provide a suitable set of operating and maintenance instructions in a way the householder can understand, in plain English. okay? The instructions should explain the important function of system to provide fresh air and to remove harmful pollutants and moisture content. How the system is intended to work, why the system should not be turned off, why you shouldn't block background ventilators, how the controls should be used, what do they show, it's working properly, and that is the fault that is happening if there is that indicator. And when the system should be cleaned and maintained. I know of an example of a very well insulated and well airtight dwellings with MVHR, and the owner did not check the filters until 3 years afterwards. So if you think that person was living in a healthy environment, you're mistaken. Okay. Guidance on the operation of the controls and how a fault is indicated and what they mean. Okay. All that in plain English. We also introduce a new provision in 1.2.1.2, so general provision, that ventilation systems, general provisions, that means it is for all ventilation systems. They should be designed by competent designers, installed, balanced, and commissioned by competent installers. Okay, so ETB is present here today, and we have Kevin and Imer will be talking to you this afternoon. So that's the first point, competency at design and installation. Second point, systems when commissioned and balanced should then be validated by a competent person to ensure that they achieve the design flow rates, okay? Not 30% off, what do you think? And that validation should be carried out by a person certified by an independent third party to carry out this work, the NZEB, and we have the manager of in the NZEB who looks after air tightness scheme, the ventilation validation scheme, and the thermal bridging scheme. Okay, Gary also. So we're going to go into two provisions, competencies. Waterford and Wexford Educational Training Board has put together a suite of training courses to cover the entire supply chain, okay, in any escorting. It covers NZEB fundamental awareness, okay, and I will encourage all designers, architects to attend this course, but also all trades, electrical, plastering, carpentry, bricklaying, plumbing, site supervisors. It covers new dwellings, but also renovation, okay, the big business for the next 40 years is renovation. Renovation is going to take over from new dwellings, okay? And when you renovate a brand new, when you renovate a building, there is no embodied carbon in it. We have a special course on the installation, design, installation, and commissioning of ventilation systems, and they also have a course on the ventilation measurement proficiency text that all validators from the NZEB scheme must pass before they can actually apply to the NZEB to be a validator. Those courses are covered under the Skills to Advance funding from SORAS. That means they are free. And their quality assured by City Guilds. And those courses have just been awarded by NZEB the product award of the show at the latest energy show last month in the RDS. So it's good stuff. That's what I'm trying to say, to tell you. So far, they have trained in excess of 1,500 people, professionals, okay? Mostly fundamental awareness to NZEB. Once again, it's key for every designer. You should be doing this. Ventilation is the second most attended, so that's good news for us. The market is becoming aware that ventilation is just as important as energy efficiency. Retrofit just reflects the market also is moving towards a retrofit from new build. You can see here we have currently 65 people who passed the proficiency test. So that means we have a number of potential validators as big as the current scheme for air tightness. So there is no problem of supply to the market. Okay, it was one argument I heard when we introduced it in 2019. Who is going to do those testing? We don't have a problem. We have a similar capacity to the air tightness. And all those people, most of them are also air tightness testers and BR assessors. So they have a very holistic view and they understand very well the level of attention and details that you require for ventilation systems. So Imer will be giving you a presentation about this and give you a test for what they do in this course. This is their website. I encourage everybody to avail of that good, free, quality assured training. That's for the first point of general provision. The second is on validation, so clause 1.2.2.11, 1.2.3.13, so that's for CMEV and MVHR. Ventilation systems, when commissioned and balanced, should then be validated to ensure that they achieve the design flow rates by an independent competent person. And clause 1.2.4.16 states the same for natural ventilation strategy. Mechanical extract fans, background ventilators, openings, and alternative system components should be specified at design stage. And systems, when installed and commissioned, should then be validated to ensure that they achieve the design flow rates for the extract fans and the correct opening areas of the background ventilators by an independent competent person, NSAI certified or equivalent. And for good measure, we also introduce that provision for all major renovations, in particular, where new mechanical extract ventilation or mechanical ventilation with recovery systems are installed as part of a major renovation, as defined in Part L, then the system should be designed, installed, commissioned, and validated, the same as for a new NZEB dwelling. A major renovation means a renovation of a dwelling where more than 25% of the surface of the dwelling envelope undergoes renovation, okay? Or if you have an extension that affects more than 25% of the surface envelope. Currently, we have 25, 26. Gary will cover this. Validators, and they're already covering the entire country. So once again, we don't foresee any supply problem. In conclusion, one thing, I forgot to say that. We've looked at the compliance rates for new dwellings when we start measuring airflow rates. So you could ask me, do we really need that provision for major renovation? Emmanuel, really. So Dr. Mary Coggins from Galway, UIG, is currently presenting in Athens this very day the results of a survey of renovated houses under the SEI deep renovation programs, 14 houses that were renovated between 2019 and 2020. So they were renovated before the introduction of TGD F and the end of the transitional arrangement. Okay, so they were done to the previous TGD part after 2009. They were insulated externally or internally, heat pump installed, and mechanical ventilation was upgraded. Most would qualify now in 2022 as major renovation. So when you start measuring the airflow rates, so they were improved from a BR rating from D1 and worse down to an A rating house, and the tightness was post-works was always below 5. So you're looking at NZEB dwellings. If I show you this graph and I don't show you was before, you're thinking A rated below 5 NZEB dwellings, new dwellings. You know, they're renovated. And when you measure the airflow rates, out of 2, 0 out of 2 did not comply, would not comply when fitted with mechanical ventilation with recovery, and only 3 in 12, so 25% would comply with MEV, okay? So in conclusion, the Ascent certifier should be providing a valid ventilation validation certificate for all new NZEB dwellings and major innovation where a new mechanical ventilation system is installed. And the building control officer should check for valid ventilation validation certificate for all new NZEB dwellings and major innovations where a new MV is installed. All new NZEB dwellings in Ireland should come with 2 certificates, a valid air tightness certificate with an air permeability below 5 cubic meter per hour per square meter, and a valid ventilation validation certificate to demonstrate that the design airflow rates are achieved on site, okay? And that is, those 2 certificates are there to demonstrate their evidence that the building is well insulated, built height, and ventilated right. Okay, we need to achieve in terms of design and installation of ventilation systems in Ireland the same achievement we have achieved with air tightness, the same level of attention and details on site with regard to tapping and jointing. And we've done it, and there's no reason why we can't do it with ventilation. So you need, for new NZEB dwellings, you need 2 certs. If an assigned certifier arrives with an air tightness test report only, the first question to ask is, where is the ventilation cert? And vice versa. That's me done.